Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to explain you the concept of problem solving on TLS record protocol operation. TLS record protocol operation. So TLS stands for what? Transport layer security. Transport layer security. So which contains to provide the security of the web and related to the information the protocol is being used. So TLS record protocol provides two types of services for TLS connections. Two types of services for TLS connection. So the TLS comes after 1990s, after 1999. Before it was named as SSL, Secure Socket Layer, but after 1999 it is named as TLS, and it is one type of extra layer of the security for the web which is above transport layer, which is above transport layer. So after above the transport layer, above the TCP protocol, above the transport layer, which provides an extra layer of the security, that which consists of this TLS record protocol. TLS record protocol. So which contains two types of services. One is what? Confidentiality, and the second one is what? Message integrity. So for these purposes, for these services, it provides TLS connections and TLS sessions. So here we'll go. TLS protocol provides two services for TLS connections. One is confidentiality and the second one is message integrity. So for the purpose of confidentiality, maintaining the information is to be secure and private. So we need to maintain that confidential information. So the confidentiality terms refers here. The handshake protocol defines a shared secret key. It defines a shared secret key that is used for conventional encryption of TLS payloads. For the TLS payloads, it uses conventional encryptions. For that, it applied a shared secret key. So what it does understand that handshake protocol defines a shared secret key that is used for conventional encryption purpose of TLS payloads. And the second one is what? Message integrity. The message could not be lost their originality. So message cannot be tried to altered. The message cannot be modified, and it should be an integratable. So the handshake protocol also defines a shared secret key that is used to form a message authentication code. So by applying message authentication code, which does not alter the message, it does not able to alter the message. So because of that MAC applies, because of that message authentication code applies, the message integrity never loss. In the TLS connections. In the same way, conventional encryption also, by using conventional encryption processes, the message confidentiality is never lost. So the record protocol takes an application message to be transmitted. The record protocol takes an application to be transmitted and fragments the data into manageable blocks. So the message is going to be divided into fragments and fragments data into manageable blocks. Optionally, it compresses the data and applies MAC, applies encryptions, add some header and transmit the resulting unit in a TCP segment. So to do not lose that confidentiality and the message integrity, it should be applies with the help of message authentication code and the encryption process and adding some headers like encapsulating headers or authentication headers and transmit the resulting unit in a TCP segment. While coming to the receiver side, the received data are decrypted then verified, then decompressed. And after decompression, it should be reassembled. So before being delivered to the higher level of users. So higher level of users. So each and every message is being transmitted from first layer to seventh layer. So each message is transmitted from first layer to seventh layer. So when it moves, the message is moved to the first to second layer. It has to apply max. It has to apply message authentication code. It has to apply encryption process and adding some headers and then transmit to the second layer. Then transmit to the second layer. At the moment of second layer, the received data are decrypted, then next verified, and then next decompressed and reassembled to the data. It forward to the next layer. It forwarded to the next layer, that is third layer. Like the way third layer to fourth layer to fifth layer to sixth layer, and seventh layer. So for all the layer, message being transmitted from first layer to seventh layer, it applies MAC message authentication code, encryptions, and adding headers and transmitting the result to the next layer. So the next layer receives that all. After that receiving, it should be the decrypted, it should be the verified, it should be the decompressed and reassembled. Then next it should be forwarded to the next layer. It should be forwarded to the next layer. So like the way the message could not be lost their confidentiality and integrity by sending from one layer to another layer. From sending one layer to another layer. So here we can observe that the TLS protocol operation. So this is what actually message that is nothing but an application data which is nothing but a sequence of messages. So if all the messages may not be transmitted to the next layer or next level, so that the message is going to be divided into some manageable blocks. Message is going to be divided into some manageable blocks. So that blocks are nothing but fragments. So each individual block, this is one block, this is one block, this is one block. Each individual block is called as a fragment. So fragmentation, the process of dividing that message into manageable blocks is called as fragmentation, and each individual managed block is called as fragment. Each individual block is called as fragment. After that, each fragment is going to be compressed. Each fragment is going to be compressed with the help of some compression algorithms. Like zip algorithms. After that compression, it applies MAC. So message authentication code. It applies the message authentication code applies to that compression. Message authentication code applies to the compression data. After that, applying message authentication code, it should be encrypted. So encrypting the data which is added MAC. So the message which is added MAC is going to be encrypted for the next level. After that, applying the headers, or else appending TLS header to the compressed data. So after compression, after adding that header, it should be delivered to the next layer. So like the way each and every layer is going to be transmit the message from one layer to another layer by doing all this protocol operation. So what the procedure is applied here, the message which you want to send to the next layer is going to be treated as message or application data, and that application data or message is divided into manageable blocks. Each individual block, the process of dividing this manageable block is called as what? fragmentation, and each individual manageable block is called as what? Fragment. So this is fragment 1, fragment 2, fragment 3. So each fragment is going to be compressed with some compression algorithms. Each fragment is going to be compressed with some compression algorithm. Then next, apply or add message authentication to this compressed data. Applying or adding message authentication code to this compressed data. The next, encrypt encrypt the data which is already applied message authentication code. So encrypt the data which is added MAC. Then next, append TLS header to above compressed data or to above encrypted data. So append TLS header to above encrypted data. So once it is appended, once all these operations are performed on that message, is ready to deliver to the next layer. And after receiving that message by the next layer, automatically the next layer is going to be decrypting that message, the next verifying that message, and here decrypting that message, verifying that message, decompressing that message, and reassemble that message. So here we can see all the steps. The first step is what? Fragmentation. And each upper layer message is fragmented into blocks of 214 bytes or less. It may be 214 or less. The next, compression. It is optionally applied. So if you want to reduce the size of that message, you can apply compression process. And compression must be lossless. So may not increase the content length by more than 1024 bytes. In TLS V2, no compression algorithm is specified. So the default compression algorithm is what? Null. So there is no compression process and there is no compression algorithm for doing compression process. And the next step is processing is to computing message authentication code. So computing message authentication code. So after compress the data, it is adding with the message authentication code. So over that compression data. So here the TLS makes use of the HMAC algorithm. That is nothing but hash message authentication code. Hash message authentication code over the compressed data. So which is defined in RFC 2104. So here request for comments 2104. So the formula is to applying that message authentication code to this message is what? HMAC of M. That is nothing but the applying hash message authentication code to the message equals to H of K plus of optional pad or bar H of K plus of optional input pad with message. So applying input and applying message. So all this input pad and output pad, input pad and the optional pad is added to this message. So that we can understand that here H equals to embedded hash function, and M indicates that what? Message input to HMAC, where K plus equals to secret key padded with zeros, on the left, so that the result is equal to the block length. Of the hash pad. So input pad, so that is nothing but 001 10 1110. The optional pad which is repeated 64 times. So for TLS, the MAC calculation encompasses the fields indicated in the following expression. The expression you can write it was HMAC underscore hash of MAC write secret and the sequence number TLS compressed type. Then next, TLS compressed version, TLS compressed length, TLS compressed fragment. So this is for this all the things the hash function is applied HMAC algorithm. So what are those? MAC write secret sequence number, The next TLS compressed type, and TLS compressed version, the next TLS compressed length, the next TLS compressed fragment. TLS compressed fragment. So for all these sequence number, writing secret, compressed one, compressed type, version, length, and a fragment. For all these, the hash function is applied. For all these, hash function is applied. So here, the MAC calculation covers all of the fields such as XXX example, and plus the field TLS is also compressed. Plus the field is also compressed, which is the version of the protocol being employed. Which is the version of the protocol being employed. Next, the compressed message plus. So whatever the compressed message plus the MAC are both are encrypted. So compressed message plus MAC, which both are encrypted using some symmetric encryption algorithm. Encrypted using symmetric encryption algorithm. So encryption may not increase. The encryption process is may not more than it is not increase the length by more than 1024 bytes. Should not be increased. It should be on the limit of 1024 bytes, so that the total length may not be exceed 214 plus 2048 bytes. 214 plus 2048 bytes. So here we can see the following encryption algorithms are permitted. So here the block cipher and the stream cipher, they allows up to the particular bytes of data. So here the block cipher, the algorithm AES, advanced encryption system allows up to 128,256 kilobytes bytes, and 3 days, the triple days indicates that 168 bytes. And the stream cipher, in that stream cipher, RC4 to RC128 indicates that 128 bit size. So here from a stream encryption, for stream encryption, the compressed message plus the MAC are encrypted. So one is compressed message plus MAC is going to be encrypted. So this compressed message plus MAC is going to be encrypted. And the MAC is computed before encryption takes place, and that the MAC is then encrypted along with the plain text or compressed plain text. So the MAC applies before encryption process, after compression process. So after compression process, MAC applies, and before encryption process, MAC applies. So for block encryption, padding may be added after the MAC prior to the encryption. So that is what we told before that. So the padding is in the form of number of padding bytes followed by 1 byte indication of the length of the padding. 1 byte indication of the length padding. The padding can be any amount that results in total, that is a multiple of cipher's block length. It is up to maximum 255 bytes. It is up to maximum 250 bytes. So for example, if the cipher block length is 16 bits, if the cipher block length is 16 bytes, like example advanced encryption standard, and if the plain text is compressed text, if compression is used, plus MAC plus padding length byte is 79 bytes long, then the padding length can be 1, 17, 33, and so on, so up to 161. So at a padding length of 161, the total length is 79 bytes long plus 161 padding length. So 79 bytes plus 161 padding length equals to 240. So here a variable padding length may be used to frustrate attacks based on analysis of the length of exchanged message. So analysis of length of exchanged message. And after that all, the final step of TLS record protocol processing is to prepend a header consisting of the following fields. What are those? So one is content type 8 bits. So the higher layer protocol used to process the enclosed fragment. The higher layer of protocol used to process the enclosed fragment. The next major version of the bits indicates that major version of TLS in use. For TLS, the value is what? 3. So example indicates. And minor version, it is also 8 bits, indicates minor version in use. Minor version in use. For TLS-V2, the value is what? 1. The value is what? 1. And the compressed length, it is 16 bits. The length in bytes of the plain text fragment, the maximum value is what? 214 plus 2048. So one is 214 is what? Bytes long, and the 2048 is what? Padding length. 2048 is what? Padding length. So the content types that have been defined are, so the content types in the fields content type is there. So content types that have been defined are what? Change cipher specific and alert protocol and handshake protocol, right? So change cipher specific protocol, alert protocol and handshake protocol, and application data and application data. So here the first three are the TLS specific protocol. So what are those? Change cipher specific, alert, handshake. Those three are the TLS specific protocols. TLS specific protocol. So here the change cipher specific protocol. The change cipher specific protocol is one of the four TLS specific protocols. One of the four TLS specific protocols that use the TLS record protocol. That uses what? TLS record protocol. And it is a simple protocol. And it is a simple protocol. This protocol consists of a single message. So here the change cipher specific protocol is one of the protocol for all the TLS specific protocols, and it uses TLS record protocol, and it is a simple one, and it is the simple protocol. And this which consists of a single byte with the value 1. Single byte with the value 1. So the sole purpose of this message is to cause the pending state to be copied into the current state. So which updates the cipher suit to be used on this connection. Cipher suit is used on this connection. So this is the TLS record protocol, which contains the content type, which contains the major version, minor version, and the compressed length, and here the plain text which is optionally compressed, and MAC which is added with MAC. So all this padded data is what? Encrypted data. All this data is what? Encrypted data. So here alert protocol. The second one is what? Alert protocol is used to convey TLS related alerts to the peer entity. It indicates that what? It gives the notifications, or it gives the alerting messages to the systems or to the networks. As with other applications that use TLS, alert messages are compressed and encrypted. So alert messages are compressed and encrypted. So as specified by the current state. So by the specifying current state, it indicates that the next messages are compressed or encrypted. So here the four protocols, like a change cipher specific protocol, contains only one field and its size is 1 byte. And alert protocol is having two fields, like level of that protocol type and what is the protocol. So level of the protocol and the type of protocol. So which contains both 1 byte and 1 byte. And handshake protocol, so which consists of three fields: the type of the protocol and the length of the protocol and the content that carrying by the protocol. So that is, type is 1 byte and the length of the protocol is 3 bytes. Length of the data is 3 bytes, and the content of the protocol takes is greater than or equals to 0 bytes. And other upper layer protocols that indicates that what? Application specific specific protocols, which is greater than or equals to 1 byte, which is greater than or equals to 1 byte. So this is all about TLS record protocol payload, TLS record protocol payload. So all these protocols contains individual fields and individual size of that fields, individual fields and individual size of that fields that carry. So here each message, each message in this protocol consists of 2 bytes. Each message on this protocol contains 2 bytes. The first byte takes the value warning or fatal to convey the severity of the message. To convey the severity of the message. If the level is fatal, then TLS immediately terminates the connection. So TLS connections, we know that what TLS connections under TLS sessions. So once if the level is fatal, then TLS immediately terminates the connection. TLS immediately terminates the connection. And other connections on the same version, other connections on the same session may be continued, but no new connections are allowed. So, but no new connections has to be established on this session. So the second byte contains a code. The second byte contains a code that indicates the specific alert. That indicates what? Specific alert. So first one indicates what? The same session, same connection, but it is not going to be establishing new connections. But the second byte contains what? The code that indicates the specific alert. So example of fatal alerts are like bad record MAC, that is nothing but incorrect MAC was received, and a handshake failure. So this is also one type of fatal alerts, a handshake failure that indicates that what? Sender was unable to negotiate an acceptable set of security parameters given in the options available. So sender was unable to negotiate the acceptable set of security parameters given in the optional available. So an example of warning alert is unsupported certificate. So this is one alert, this is one warning alert, and fatal alerts. So fatal alerts. These are all the alerts are given by what? Alert protocol. All the alerts are given by alert protocol. So that is about this TLS record protocol operation, which contains different protocols like cipher specific protocol and alert protocol and handshake protocol. All these protocols are implemented in the TLS architecture to provide an extra layer of the security for the web. An extra layer of the security for the web. So once again we revise the topics which we discussed in this session. So here the TLS record protocol operation, which establishes two services for the connections. One is what? Confidentiality and message integrity. One is what? Confidentiality and message integrity. And here the protocol operation existed. The application data is going to be divided into manageable blocks. Each individual manageable block is called as fragment. The next, each fragmented data is going to be compressed. The next, the compressed data is going to be added with the message authentication code. The next, the added message authentication code data is going to be encrypted. Then add header, append TLS header to that encrypted data. So after performing all these operations in the first layer or in the upper layer or lower layer, it moves to forwarded to the next layer by this all the operations are performed. So here the operational steps and applying hash function HMAC authentication code and applying with different types of encryption algorithms like block ciphers, string ciphers and all. So this is all the chain cipher specific protocols, which contains format of the real record like content type, major version, minor version, compressive length, and the plain text, and these are all encrypted data. And the alert protocol along with the bytes, along with the fields and the size of the fields, along with the fields and the size of the fields. So fields and the size of the fields. So all these protocol fields are having certain types, certain sizes, and each individual messages which alerting the messages like fatal alerts and warning alerts, such as like unsupported certificate, bad record max, handshake failure. All these types of alerts are being displayed. So this is all about the record protocol operation, which contains different types of protocols that are used to provide an extra layer for the security of web. Security of web. So this is all about the record protocol operation. Thank you all.
Like, share, and subscribe. Hit the bell icon for more updates.